Good afternoon, students. So today we are going to start with our second practical. Already, some students have submitted me the first write-up for the first experiment. As we have taken, I have given the path for drive, and already many of you have submitted that assignment. So practical number 1 was study write-up for the given command for C language, and there how the compiler works for every phase that we have to discuss, and the write-up about compiler construction tools. So that was based on chapter number 1, unit number 1. And now we are going to start with second practical, which is based on unit number 2, that is lexical analyzer generator. So we will start within a few minutes because still only 11 participants have joined. So we will wait for another 5 minutes and then we will start with the practicals. Okay, so let us start with the practical. Okay, are you able to see the whiteboard? Yes, reply fast, students. Whiteboard is visible. A division 10 roll number, Rutuja. The whiteboard is visible.
Yes, ma'am.
Okay, so I believe now the whiteboard is visible. Okay, thank you, thank you. Right, so our second program is lexical analyzer generator. So we are going to generate the lexical analyzer. So we already know what is lexical analyzer or what lexical analysis means. So first thing is, whenever you are having the input program, the job of lexical analyzer is to convert that program into number of tokens. So like see, this is your lexical analysis phase, and here I am passing a source program to it. So the source program may contain hash include stdio.h and all, right? So here this is first line, then you are having the main function, then you are having the opening bracket, closing bracket, printf statement, right? So this is your program, source program, which you are passing to the lexical analyzer. And as output, you are going to get that this hash include stdio.h is a preprocessor directive. So you are going to get output like this. So hash include stdio.h is a preprocessor directive. So in short, I will call it as PD, preprocessor directive. Then main is a function call. So I will have the second is main is a function call. So you are going to separate every token out of your program. Then opening bracket is the special symbol. Then printf is again a function call, and closing bracket is special symbol, like that. So whatever you are going to use, if any keywords you are using, integer, float, etc., in your program, so they are also getting distinguished as, or they are going to determine, we are going to determine them as keywords. Okay, so to carry out this, we should write some code over here for this lexical analyzer. So we are going to write a program over here, which is having the .l extension, which will have the .l extension. L stands for lex tool. So we are having the tool, which is called as lex tool, and we are writing some program. Let us write the name of the program is LA generator. So I will have LA lexical analyzer generator .l. So this is my input source file. So you can write it in a notepad, you can write it in WordPad, or even you can write it in your dev C++, but you have to store it with .l extension. Okay, that is the only requirement. Now, what is the syntax of this lex file? So this lex file is having a fixed syntax. The first is always the declaration section. The first section is always declaration section. Then you are having double %sign. So this double %sign is used for separating the declaration section from the rules section. So second section is rules section. So when I use this double %sign, meaning is the declaration section is over and now this is your rules section. After rule section, again, I am going to use this double %sign, which is indicating the end of the rules section. And after that, you are going to have the auxiliary procedure section. So I will call it as auxiliary procedure section. Okay, so total 3 sections are there in any .l file. कोणतीही लेक्सिकल टूलची जर फाईल घेतली तर त्याच्यामध्ये 3 सेक्शन्स असतात. फर्स्ट डिक्लेरेशन सेक्शन separated by double %sign from rules section, and again rule section is separated from auxiliary procedure section by means of double %sign again. So that is called as your structure of .l file. After this, once you write the program in this, okay, one more thing, that rule section has a typical syntax again. So you have to write a rule here that is nothing but the pattern. We are going to call it as a pattern because pattern decides actual how the lexeme to be. म्हणजे एक lexeme or token हे कसं असेल, so that is represented with the help of a pattern. So pattern is always in case of regular expression kind of thing, which will take form of any type of tokens, right? So pattern is first thing. So rule section includes pattern followed by action. So here you are going to get the action. Suppose this pattern is matched, then which action you have to take, that is written inside this curly braces over here. So that is the syntax of the rule section. You have to specify the pattern, and by keeping some space, you have to write the action in curly brackets. Okay, so that is how the rule section is specified. And in the procedure section, same as that of your main procedure, you are going to read the input, you are going to process on that, and you are going to get the output out of it. Okay, so this is the structure of the lex file: declaration, then rules section. Rules section is having a particular syntax like pattern and corresponding action. And after that, you're having the auxiliary procedure section, which is containing your main functions or any user defined functions also. So in this auxiliary procedure section, you have total 3 functions written. So always 3 functions are there. One is your main function, where you are going to write the program, what you need to carry out. The second is called YYLex. This is the one more function which reads the input. So the job of YYLex is to read the input. Here we are passing this program as a source program, that is the input program. So the job of YYLex is to read this complete program and then separate it into tokens. So the job of YYLex is to read the input. And then you have YYWrap. So YYWrap is the function which determines whether the input is over. So wrapping up of input, that is, once your input, this file is ending, then YYWrap will return the value as 1. So the job of YYWrap is to return 1 once the input file is over. Okay. So these are the 3 main functions we are going to write in each and every .l file. Okay. Is there any difficulty up to this? All of you are getting? Okay. So I'm getting the output as no difficulties. Okay. In chat box. Okay. So this is the way how we are writing the program. So .l file, it has this syntax. To this .l file, we are passing the source input, source program as the input, and we are going to generate the tokens as output. Okay. Now, this is it. Once you write the code in this file, so this is your LA generation.l. The file name is this. So how to compile this file and how to execute the file, right? So this is your .l. So normal C program जसं आपलं compile होतं आणि execute होतं तसे हे .l होणार नाहीये. So we need some another compiler for that, and the name of the compiler is Flex. So all of you have to download this Flex and Bison for our computer practicals on your machines. So these are the 2 compilers. Flex indicates Lex tool and Bison indicates Yak tool. It is used for the parser. So Flex is there, which is the Lex tool, and Bison is working as a parser. So Bison is acting as a parser, and it's called as Yak tool, YACC. YACC stands for yet another compiler. So YA, yet another, and CC means compiler. So Yak is the tool here used in case of Bison, and Lex is lexical analyzer generator. So first thing is you have to compile it with Flex compiler. So Flex and file name.l you have to write. So file name is lagenerator.l. So when you write this on command prompt, so on command prompt, you have to write this where the location of your file is there. From that location, you have to run. So flex file name .l. Once this compilation is over, this file is getting converted into lex.yy.c. So this is very important thing, that the .l program is first compiled with Flex compiler, and then we are able to generate the output as lex.yy.c, which is a C program now. So now this has the extension C. Okay. So after this compilation of L file, we are getting lex.yy.c. Whatever may be the name over here, इथे LA generator लिहिलं किंवा मी जर lexical analyzer generator पूर्ण नाव लिहिलं तरी सुद्धा मिळणारी फाईल ही lex.yy.c हीच असते. Okay, so whatever may be your file name, after performing flex compilation, you are going to get fix name file, that is lex.yy.c. Once you get this lex.yy.c, next step is you have to do the C compilation now, because this is your C file. So for this C file, you have to perform the C compilation. And once the C compilation is done, then I am going to get exe file, or it is also called as object file. Okay, so once you compile it with C compiler, then you are going to get the object file or executable file, and the name of that file is always a.exe. Or if object file is there, then you are having the ./a.out. This is the name of the file getting generated after performing the C compilation. Okay, so this object file is ./a.out. Executable file is a.exe. Okay, and then for this ./a.out, I will pass this source program. So after this ./a.out or a.exe, then I have to specify the name of the file as source.c. मग मी ही file as an input पाठवणार, which is your source.c file. And then this is your object code, which will separate out the token of this source file. This is the object code which is responsible for separating out the tokens from source.c. And then you will get the output like this. Hash include stdio.h is a preprocessor directive, main is a function call, opening bracket is a special symbol, and so on. Okay, so these are the steps of writing the, or instead of writing, I can say the steps for compiling the Lex program. Okay, shall I wrap this? Okay. So before we start with the actual program, let me show you the Bison and Flex. Okay. So when in the Google, you type about Flex, So you are going to get this 2.5.4a. So this is the latest version of Flex. So on Windows with this Flex 2.5.4a, you can download this and you can use this Flex as a Lex tool. So here the Flex GNU Win32, this is the link available. So you can download the setup file. So I will show you by opening this. So you can see here, the setup file is there. So you can click here and the setup file will get downloaded, and that you have to run as administrator so that you can get it installed. This is the package. Similarly, for Bison, this is the version 2.4.1, and Bison for Windows, this is the path available. And here is the setup, or even here you can go with setup program. So you can download the setup program by clicking here, or you can download it by clicking over here, right? So both the things you have to download on your computer, and then run them, both of them, and then you are going to install the Bison and Flex on your system in program files. Okay, in program files, there you have to set the path. There you have to set the path. So how to set the path? I will show you. Okay, so this is the folder, you can see. Okay, so once the installation is over, in the program files, in the C drive, the program files are there. There you will find this GNU Win32. So this is the folder which is containing the Flex and Bison both. So I will open this, and after that I will copy this path. So I will copy this path, and then I will go to the environments. So I will write here environment. That is nothing but the system environment variables I am going to set. So I'm opening this. Here also environment variable is one tab. So you can click on that. And then you have to set the path. Here path is there, system variable path. And in this path, I'm going to edit. And there I will paste a new. So I will write new, and I will paste this path of GNU Win32 bin over here. Once I will paste it over here, then I will click OK. And again OK here. So in this way, I'm going to set the path of Bison and Flex in my system environment. Okay. And once this is done, then you are able to write the program in text editor. So simple text editor is also sufficient. So I will show you one program. Lex one, let us see. So you can write it in a notepad and then you can save it. You can write it in the notepad and you can save it later. Okay. So this is a very simple program. I have written, which will tell you about the syntax of the file. So here is the first. Okay. So you can okay. Right. Okay. So I have increased the font. Right. So you can observe here double percent sign is there. So before double percent, whatever is available, that is considered as your declaration. Right. Whatever is available at the top before this double percent sign is considered as declaration. The middle portion between two percent signs, between two double percent signs, so whatever is there, which is called as your rules section. And the last portion after this double percent sign is considered as your procedure section. So it is called as auxiliary procedure section. Okay. Now here there are two type of declaration. The declaration which is used in the local file. Local file means .l file. The declaration which is used inside the local file, that is whatever the actual file here, lext1.l. This is the name of the file. So whatever the variables we are going to use in this local file lex1.l, those variables are declared without any curly brackets. म्हणजे ज्या variables declaration is used by the local, that is .l file inside this program, then those declarations are not required to declare with these percent and opening closing brackets, not required. And the second is the declarations which are used by your .c file, that is lex.yy.c. एक तर .l फाईल मध्ये यूज होतील डिक्लेरेशन्स किंवा काही व्हेरिएबल्स आहेत ते .c मध्ये होतील, कारण अल्टिमेटली द .l file is going to be converted into lex.yy.c, right? So there are two type of declarations. Now this particular declaration is having the percent sign opening bracket, then percent sign closing bracket. So all these declarations, they are enclosed within the curly brackets, and that's why they are used in .c file. बरोबर आहे, कारण hash include stdio.h we don't want in our .l. We require it in case of .c file. आपल्याला ती .c मध्येच लागेल जेव्हा ते lex.yy.c झालेली असेल तेव्हा. So these declarations which are enclosed within the percent and closing opening closing curly brackets, they all are part of your C program after conversion or after lex compilation. Then after these declaration, if I am using some variables like let us say id, identifier. आयडेंटिफायर हे एक व्हेरिएबल आहे आणि त्याचं मी डिक्लेरेशन करत असेल की आयडी शुड स्टार्ट विथ स्मॉल a to z, किंवा capital A to Z followed by अंडरस्कोर असेल किंवा 0 to 9 असतील किंवा A to Z असेल किंवा कॅपिटल A to Z असेल. तर मी काय केलंय, आय हॅव डिफाईन्ड आयडेंटिफायर विथ दिस रूल. मी डिफाईन केलंय की आयडेंटिफायर कसा असतो, इनिशियल कॅरेक्टर फर्स्ट कॅरेक्टर इज अ letter followed by any combination of letter, number and underscore, right? So any combination, that's why star will be kept over here. So this id I will be using inside this .l program. हे id मी कुठे यूज करणार आहे, या .l program मध्ये यूज करणार आहे, and that's why this is called as local declaration and it do not require this opening closing curly brackets and percent signs. Okay, so this is called as local declaration. Now after declaration you have the rules section. So we have seen the rules section is having a particular syntax, and what is that syntax? Pattern and action. So here the closed square bracket indicate the pattern and the corresponding action is specified within the curly brackets. Okay, so here what we are doing, we are writing the rules here, and based on these rules the corresponding action is taken. So the small program here I have written is to count the number of vowels and consonants. Vowels म्हणजे काय, A, E, I, O, U. ते जर असतील तर त्याला vowels म्हणतो आपण. And apart from them, whatever the alphabets are there from A to Z, small a to Z or capital A to Z, all of them are considered as consonants. So rule काय येईल मग, इथे फिक्स आहेत AEIOU स्मॉल किंवा AEIOU कॅपिटल, यापैकी कोणताही आला तरी तुम्हाला काय करायचंय, वोवेलचा काउंट एकनी वाढवायचा आहे. सो इन माय सी प्रोग्राम मी काय करणार आहे, सी प्रोग्राम मध्ये मी हे वोवेल्स अँड काउंट्स व्हेरिएबल्स यूज करणार आहे. दॅट्स वाय दे आर डिक्लेअर विदिन दिस कर्ली ब्रॅकेट्स. पहिल्यांदा वोवेल्स अँड काउंट दोन्ही इंटिजर व्हेरिएबल 0 ला सेट केलेले आहेत. इनिशियली vowel and consonant दोन्हीच्या व्हॅल्यू 0 आहेत. And once it will start reading the source code line by line, then it will check for the occurrence of vowel or occurrence of consonants. Occurrence of vowels or occurrence of consonants. Okay. मग मी इथे OR दिलेलं आहे. ही vertical line represents OR. So A असेल किंवा small e असेल किंवा small I O U. So either AEIOU small असतील or AEIOU capital असतील. If any one occurrence of this square bracket काय indicate करतं, one occurrence of the elements. If any one occurrence is there, then I will say I have found the vowel in the code. And that's why I am increasing the value of vowels. So vowel will get increased by 1. Okay, so this semicolon indicates the particular rule is over. Next, as soon as it find the second line, it will start execution from the first line again. So next is occurrence of small a to Z to capital A to Z. यामध्ये काय होतं, पण स्मॉल ए टू झेड मध्ये पण AEIOU येतील, कॅपिटल ए टू झेड मध्ये पण AEIOU येतील. बट द बेस्ट मॅच इज फाउंड आउट. बेस्ट मॅच कशाशी आहे, पहिले इथेच चेक होणार आहे, पहिले इथेच चेक होणार आहे. सो अपार्ट फ्रॉम AEIOU स्मॉल और कॅपिटल, जर दुसरं कुठलं कॅरेक्टर असेल तरच ते या बॉक्स मध्ये डिटेक्ट होईल. and which will be considered as consonant. तेव्हा consonant ची value वाढेल. Okay. So तेव्हा काय होईल? Consonant ची value increase होईल. So when a particular rule is matched, what corresponding action you have to take is specified over here. So this pattern, for that pattern, this is the action. Okay. And then comes our procedure section. So in the procedure section, we are having the YY wrap, integer YY wrap. I have just told you it is indicating the end of your source program and it is returning one value so that we can understand, yes, we have finished with our file. So it will return value equal to 1. Next, in the main program, what I am going to do is I will accept the string from the user side. String म्हणजे काय तुमचं input file आहे. So in this input file, I will check what are the number of vowels and what are the number of consonants. Okay. So first thing is it will enter the string at the and at the end you should press enter key. You should press enter key so that it will realize that end of the line has been occur. That means you have finished giving the input string. Okay. So enter the string and at the end press enter. Then you are calling yylex. So just now I told you yylex is the function which reads the input. It will read the input one by one symbol. And that is the job of yylex. And next is I am printing how many vowels are there. So vowels is equal to %d and the variable that will be getting printed as vowel. So the variable that I am using over here, vowels, the same variable I'm going to print with number of vowels in the input file. And next is consonants. So I'm going to read those number of consonants. So this is a very simple program. Okay. So in the same manner, we have to write the code for generating the lexical analyzer. Okay. So once we write this program, we have to store it with .l extension. And in the .l, you have to run that. So 1 second, I will show you this execution of the program. Wait for 2 minutes. Hello. Am I audible?
Yes, ma'am.
Okay. Just wait for 1 minute. Actually, one this GCC CCE compiler is not getting recognized. 1 second. See, I have one. Okay, so in C drive, I have stored that in program files. I am having that GNU Win 32, in which I am having both Bison and Flex, right? Bison and Flex. So this is after installation. Once we install this, next task is to write the program. So we have written this program. Just now I have shown you this Lex one, right? This file we have already written, and we want to count the total number of vowels and consonants in our input file, right? So that is the program available with us. The name of the program is Lex1. So you can find here the lex1.l file is there. The extension is L file. Okay. So I will be using command prompt from this particular location, so that it will start with E drive only. And the first command is flex, because our lex file name .l extension is there, and we are going to compile it with the flex compiler. So flex, name of the file is lex1. So you can observe here only lex1 file is there. Here lex.yy.c is not available anywhere in this folder. So once I will compile it with Flex compiler, then only this lex.yy.c file will get generated. So Flex and file name .l. So lex1.l. After compiling this, then you can see here the last file which is getting generated is your lex.yy.c. Then this C file, I am going to compile it with C compiler. So GCC, or simply CC also, CC lex.yy.c, and minus LL is for link library, because sometimes library elements are not, all the library elements are not available with CC. So externally I am linking the library. So minus LL stands for link library option. But I'm not getting here the output actually. I'm getting this error. So I will resolve this. And it is saying that CC is not recognized. Maybe some module, while at the time of installation, some module is remaining for this CC. So it is not showing the actual path of that GCC or C compilation. So after that, what happens when CC lex.yy.c, when I will do, then here one more file will get generated, and that is the name of the file is here. One more file I will generate, and that is called as a.exe. So by default, always the name is a.exe. Here also by default, the always name is lex.yy.c. And after doing this cc lex.yy.c minus ll, you will generate this executable file. And to this executable file, the next command is, I am going to write over here that a.exe followed by only a.exe when I will do, then the program will go into our this lex file, and what it will do, it will ask for the enter the string and press enter. So here you will find that line, enter the string at end process, at end press enter. So this line will be there, and here if I am writing Pandharpur string, so you will find this particular enter the string here. Once you execute this a.exe, you will get the line over here, enter the string, and whenever I am pressing Pandharpur, I am writing the Pandharpur over here, then it will scan this total string. P, for P, it will count the consonant, because consonant is not ranging A-I-O-U, capital, small, genustil, that will be considered as consonant. So it will consider P, N, D, H, R, P, and R. So total 1, 2, 3, 4, 5, 6, and 7 consonants. So at the end, you will get the number of vowels is equal to, and the number of consonants is equal to 7. And vowels are 1, 2, 3. So you will get the output like this, but due to some installation issues, I'm not getting this CC file generated. It is C compilation is not taking place. I will resolve this issue soon, and I will show the output of this in the next turn. Okay. So that is about the second practical. Here you have to, here I have given only the vowels and consonants. Now you have to write the code for all the type of preprocessor directives, integer, the keywords, then identifiers, and then function calls. So that we will see in the next turn, that how exactly the lexical analyzer tokens are getting generated. Here what we have done, we have separated out the vowels and consonants. Similarly, from the input file, we are going to separate out the tokens. Okay, so I will resolve this issue. You can mark your attendance and then you can leave. I will resolve it, and in the next turn, we will have the output of this file as well as the next practical, that is the token generation. So mark your attendance and then you can leave.